the people here the same as people who came after Gouaillard, or is it a different crowd? I mean, I feel like
I don't know. I think maybe this guy could probably tell you better. I didn't look at all the registrations.
Okay.
Well,
Not much. Huh? Yeah, 3 times. I haven't seen you for like 2 years. We were competitors, and then now I see you 3 times in 3 days.
Ça sera ce construit, c'est là-bas. Il faut faire le clic sur
La première fois, the size I control by doing just all these. I want it to take up the whole slide and fit, and then it takes up the whole slide. That's it. Everything else it fits automatically. The color, I don't know what. I guess if you have a lot of things, it makes it black. If it's just a title, it makes it white.
I like your slides usually. I remember the previous ones, but they were not made.
No, those ones I made in Keynote, but now I started using this because I don't have to code highlight. It does it for you. You just use a markdown. You just do you just use Tokbox like markdown, and it highlights it.
That's very cool.
Yeah, I like it a lot. The only problem is it's not free. It's like I think it was like $20. No, just one time. I was making slides for a conference, and someone else was using this, and then I said, "Oh my God, I haven't made my slides yet. I want to do it fast. I don't want to worry about the fonts and stuff." So I just did this, and then it helped me so much. So it was worth the $20.
Yeah.
For that one talk, but now I have it forever. But yeah, it sucks that it's close.
And you have like different themes. And like,
yeah. They have different. You can just in one shot you can be like, "Oh, now it's gonna be like that," or it's gonna be like red. Or it's not that customizable, right? You have to pick that one.
I don't know.
Yeah. Oh.
China theme.
Oh, that's good. It's like JavaScript theme.
Oh. Okay.
Actually, maybe. I don't like it's too thin. It's too hard. Oh, now it's centered it. I don't like that.
Oh, so
they changed. Like you can't control it.
they're high quality themes though.
Yeah, they are. They're pretty good.
Yeah, that one is good.
Oh yeah, it's pretty good.
What about
that one?
JavaScript?
Oh yeah, the JavaScript color. Yeah,
it should
be reversed. Yeah. I don't know. This one has kind of a cool handwriting to it, you know. I think I'll just stick with for now. I'll just stick with this one. It's like,
I saw you presented in Asia. How was it?
Oh yeah, in Singapore.
Yeah.
Yeah, that was really cool because Singapore is a very interesting country.
Yeah, I heard so.
It's very organized, clean. I stayed in Chinatown.
How was the tech and like people talking about?
They were a little bit shy. They didn't ask very many questions. But I think they're smart. They're just maybe, just like much more shy to ask questions.
Yeah.
It's cultural thing or something.
Yeah, the English is not, like for me as well, like to talk English is not as natural for native.
Maybe it's just fine.
Yeah, but thanks. But it's not as easy, especially to come and speak to other people. Knows what I'm talking about. It's a lot different than when you're native. Plus, I think Americans are.
live stream for
Yeah,
just saying.
Yeah, I think.
Please don't touch it because
Did we say anything bad so far?
I don't know. I'm gonna watch the stream.
We were just saying that the Singaporean developers are a little shy when it came to asking questions in the contest. That's all. Nothing bad. You're right. Maybe English would contribute to that.
Oh, they actually have amazing English now.
Well, everyone's English was fine, but you're right. Maybe just certainty or something, or maybe
Right.
I don't know. There aren't that many events, I think, compared to other cities. Like,
Really.
yeah, I mean, yeah, I think that like there are a lot of people who are doing interested in other languages that came to the start of the conference because there's that many conferences. I don't know. We should. I mean, that was my impression. But we can ask Alex. You know, how many tech like conferences are there in Singapore? Are there a lot, or is it pretty few?
Well, there's plenty.
Okay.
There's a lot of they don't have the place, the location in Southeast Asia. So even if it's a Thai conference, they are doing it in
They do it in Singapore. Oh wow. Okay.
So there's a lot of companies that have the Asian headquarters there. It used to be a Hong Kong, and now it's mostly quite big one.
Oh, I guess I know. Wow, that's too many.
The word city assembly is there, strange. And the government is pushing on that. So
That's smart. Very smart.
right.
Right. And if people visit and they know that it's a nice country, they'll higher chances of starting a business there.
We don't have space. We don't want a factory job. We need that to manage that. So we want the added value. So we want the company to place the hit one. And we want signature to be the rest.
Yeah.
So first the R&D team on the CIO, and then the factory worker.
It's a good strategy. I like it.
But for the past few years, they changed their mind. They said we will start up. And then they're throwing billions of dollars on startups.
Nexus.
It's amazing, actually. They're wasting a lot of
Good for you.
So first, welcome to Tokbox and to this meetup focused on WebRTC. So my name is Aboukhadijeh. I'm a WebRTC enthusiast since 2010 now, so it was a long time ago. I'm a co-founder of BIS3. It was one of the first early adopters of the technology. I founded the company in 2010 in France, and also a member of the WebRTC working group. But as a startup, it's not the same as when you are working for a big company and you are contributing a lot. It's almost a full-time job to contribute to the WebRTC and the IETF, that are the two organizations that are behind the standard itself. So just to tell you that if you go to Paris, if you go to New York, if you go to Miami or Austin, I've created some meetups there just to leverage the technology and the knowledge to the developers everywhere in the US and in Europe. So 5 cities and more than 1,000 enthusiasts. I also created WebRTC Fest, which is an online hackathon where, as a developer, you can participate and you don't need to use a solution from any vendor. You're already free to use any solution to build your hack. I also funded WebRTC Stats to show the real statistics of the real usage from solutions that are based on WebRTC. So our sponsor and host today is Tokbox, company acquired by Telefonica a few years ago. Just to go right on the agenda, we are going to have Ankur Oberoi.
Close enough.
From sorry about that. My name is also terrible. Aboukhadijeh, it's Polish. From Tokbox, then Hadar from Peer5, Feross from WebTorrent, and Alex from Temasys. speaking today. So let's get started.
We should pass for the design of the
Tokbox.
Thank you. Thank you.
Can you get the HDMI? Let's see if it reaches. I know, just this thing.
Don't need that at all.
That's
don't.
fine. So, you can just move the projector forward. Sure.
You need a longer table?
I think I should be okay. Yep, should be okay. Logistics. Yay, okay, cool. Thanks for coming, everybody. My name is Ankur. I'm a solutions architect here at Tokbox. And I guess, first of all, how many of you guys know what we do or has ever heard of OpenTalk? Well, that's the majority of the room. Sorry if I put anybody to sleep. For those of you who don't know, we make the OpenTalk platform. The OpenTalk platform is this sort of WebRTC-based solution, really useful for building live communications right into whether it's web apps or iOS apps or Android apps, and it kind of takes WebRTC and adds superpowers. So I'm going to walk you through a little bit of what we do and how it works, and hopefully you guys find that interesting. So why add real time? This is kind of a question that I guess a lot of us here probably already have an answer to. But for those of you who don't, this is sort of my, oops, that's not the right one. This is my take on it. So we're all human. We've evolved to interact in real time with people, face to face. And I think those types of experiences are really valuable to bring into apps. So whether you're building an education app or a telehealth app or a customer service app, all of these things, I mean, we can do them asynchronously online with filling out a form or through some other means. But a lot of the time, the most natural experience is the one where you see somebody else's face, you get to talk to them, explain your problem, or just feel like it's more fun, more engaging. So that's why we build what we build. We think it's useful for all sorts of different kinds of things, and we hope we make it easier for people to integrate into whatever they're doing. So first of all, what is OpenTalk? So I'm going to go through a couple of things that OpenTalk gives you if you choose to use these set of tools. One thing is that it's a nice JavaScript interface. So who's a JavaScript developer, or what's the JavaScript right there? All right, cool. Same here. This is typically what the API looks like at the very minimal, right? And there's a lot of for WebRTC in the browser. And there's a lot of stuff going on in here, a lot of stuff that doesn't really map well to what you're trying to get done. If what you're trying to get done is take the video that's coming out of my camera and send it to somebody else, none of the words here to me jump out as that's what I'm trying to get done. So in my opinion, yikes. We could do a little bit better. So there's open source tools that wrap WebRTC. A really good one is Simple WebRTC, and I know there's some other ones out there that are also really awesome. We think ours is pretty great too, so I wanted to give you a quick demo of what it's like to build with ours. And this is the part that's ooh, live coding, risky. Forgive me if it doesn't work. So this is just a JS bin page. What's kind of cool is I can go to add library, and OpenTalk's actually in here. So boom, add the OpenTalk library. And then I'm going to put a div on the page. Sorry if you're not a HTML5 or JavaScript programmer, this portion might bore you, but hopefully I can get you to follow along. So this is just an element to put on the page. I'm going to call it my camera and close that off. And then over here, what I'm going to do is say ot.init session. And so what we have are a few high-level objects that we think map better to people that are trying to solve problems with WebRTC. So one of them is a session. A session's like a room where basically a bunch of different streams can be used, interacted with, published and subscribed specifically. So I'm going to go ahead and, excuse me, initialize a session. I have this handy dandy little CLI tool, optk session. Yay. Okay, so the first line it gave me is this is a little tool that I built just because I hate logging into the dashboard in the web UI every single time. So I can just say session.connect. And that's something that's high level. I kind of understand what's going on. I have to pass in an API key and a token. A token is sort of like my authentication, which is conveniently what this gave me in the next line. So I throw that in there. In fact, my API key is in this little file. Don't copy my secret. That's there. Okay, cool. So, and this is JavaScript, so everything's kind of asynchronous, right? So session.on, and I can say session connected, pass in a function. It's going to fire back, and let's just say console.log. Hello. Okay, I can run this, and hopefully enough, you guys can probably see that I got hello. So I connected to a session. The next step is really simple. So I want to send a stream out, right? There was that. I'm trying to talk about what I'm trying to get done. So session.publish, and I pass in the ID of an element. So right here I have an element called my camera. I throw that in there, and the next time I run, I get a prompt, I allow, and my camera shows up. Okay, that was really simple to add. Now, what if there are more than one person here? So I really want to build like a multi-party app where anybody who's on this page can talk to everybody else who's on this page. How much more effort is that? Turns out not that much, so I can say session.on. Another event's going to fire called stream created anytime somebody comes into the session. And then I get to just say, oh, there's an event that comes in here. Then I get to just say session.subscribe event.stream, because there's a stream that's sitting on that session. So now I'm going to make my font size a little smaller so we can see it. Hit run with JS again. Get this. Now, this is still just me. I'm a publisher. There's nobody else on this page yet. So I'm going to just pretend to be another user, open the same app on another page, run it. So I allow this, and sorry about the echo. But you can basically see now these two people with that much code are publishing and subscribing to each other, and this will scale to like 20 different pages if you want. And that was like 10 lines ago. So that's the kind of JavaScript interface we like to give to our customers to make this kind of thing really easy. There's a ton of other options. You don't want to waste too much of your time, but that's the JavaScript interface. We have a few more things that I'll just go through very quickly. So multi-party. You saw multi-party kind of in action here. Whether you realize it or not, those two streams were actually going not directly to each other, but which is peer-to-peer, but actually through a media server that we host. And our media server thinks a little bit differently about media streams than a lot of the other ones that are available from other platform vendors. A lot of people have something they call an MCU, which is kind of the middle diagram, where they transcode every single stream, and then they send a transcoded bundled stream down to each client. What we actually do is we route the streams. So the typical terminology for this is now like an SFU. It's like a stream forwarding unit. So that every single client device gets to choose, like, you know what, there's maybe X number of streams coming in, and I want to subscribe to one and put it in the top of my own page, in my UI, and maybe the rest of them I want to put in the bottom. That sort of decision can be made by your client-side front end, and each stream can be treated as like a separate primitive, which we think is like a better programming model for API developers.
Can I ask a
Sure.
Do you transcode anything when you reroute that?
No.
So like, how can it scale to like getting 10 different streams, and like what are the limitations in that case?
Sure. So we don't put any hard limit on the number of streams in a session. Really, we think that's up to the application developer to decide. But what we do is we recognize you're going to at some point hit a bottleneck, right?
Yeah.
Typically, the bottleneck is the client or the last mile of the ISP. So we have lots of hooks in our very rich API to do things like reduce the frame rate, reduce the resolution, fall back to audio only. Things like that that can be intelligently decided by an algorithm at our router end up becoming defaults that most application developers really appreciate, and then they can break out of them if they think that their application is special and to do things a little bit different.
And I can prioritize the different streams, so I want the highest quality for one stream, but lower quality as well.
Yes.
Because typically there's one speaker, or one significant speaker.
Exactly, and just to build the one speaker kind of application, you need not only the ability to prioritize, but to be able to detect who the active speaker is, right? So we have like a event-based API that gives you the audio activity level too. So you, as an application developer, can decide that.
Very cool.
Yeah.
Question here. You can touch that. Is it?
Yeah, it's well, there's one special little corner case where we're trying to do something even nicer for developers, which is if you're just going to have 2 people in a session, and it's always going to be like an iOS device to another iOS device, we do that using H.264. But everything else is VPA. And the reason we special case that is on mobile, it really matters how much battery life CPU you use. And we think if we can deliver a better experience for that simple case, then that's a good enough reason to make that case work. Absolutely, yeah. So iOS 8 and above has access to developers for the video encoding and decoding part.
So you cannot do that if you have more than 2 people because there is only one decoder unit on the phone. If you have multiple, do you still use VP8 SBC on the temporal side of things?
So we kind of need you to signal to us that you're only going to want to put 2 people in a room because we agree it doesn't make sense when you have more than 2 streams.
Right. So last time I spoke with Battery, he told me that he enabled VP8 SBC, which is on the temporal side of SBC, not the spatial side, when you're going from your native SDK to your native SDK, which is an optimization compared to Chrome, which does not enable that option. Right? Do you still do that?
SVC, to be honest, I want to give you a good answer, and I'm not sure what the latest we're playing with in SVC is. We can talk about it later, and I can try and find the right answer for you, but I'm not sure. A few real quick things that we solve, I guess you probably would have heard already. We do build iOS and Android SDKs that have very similar APIs. We give you sessions and streams and publishers and subscribers, sort of the high-level bits we like to express these applications in. We have archiving, which for all those use cases where you might typically on a phone call here, your call may be recorded for quality assurance purposes. A lot of our customers want to do recording. So what we do actually is, back to this diagram, in the routed situation, in that blue circle, we could just start recording that video to file and give you a nice API about grabbing those recordings, deleting them, listing them. We can even hook up into your own storage provider, so S3 or S3 or Microsoft Azure. We can go ahead and send those files to them. So that's something that's really cool that our platform does that you don't get out of the box.
Which layout do you choose? When you have an SFU, everybody in the conversation can have a different layout on the screen.
Right.
They can choose on the client side.
Absolutely.
So which one do you choose, if you choose any, for the final file? I understand you have 2 modes, one where each of the files is separated, and one where you mix everything all together,
yep.
in which case you need to choose the layout. Right?
Exactly, yeah. So
which one do you choose?
Right, so the current iteration we have out right now basically chooses a basic algorithm that's tile it and choose the least amount of white space but fit it in a certain container size.
So you do not base the composition on any visible screen of any
No.
participant.
Because there's plenty of use cases like the
I agree.
yeah, there's
There is
plenty, like
no
where it's just
right
like
answer to the
your
question.
call may be recorded for quality assurance purposes. The customer never sees the layout. What they want to keep that archive for is for historical purposes and audit purposes. The layout doesn't matter to them. But there are, I understand there are many use cases where the layout does matter, and that's why we enable the individual stream archiving. So you can choose to do as much processing on those individual streams as you want. We give them to you at the resolution that we got during the live stream with all the bits that we got. There's no downsampling or anything like that. There may one day be a way in OpenTalk to do something in between those 2 options. We're yet to see that. So platform availability, another thing maybe you guys have heard about is, peer-to-peer doesn't always successfully connect. But sometimes peer-to-peer is really important to your application. You want low latency and you don't want to send the data over at a possible point where it can get unencrypted. So we also have turn servers. So when you create a peer-to-peer session with us, no matter where you are in the world, we have a globally available infrastructure. This 8% that we've sort of anecdotally tested as the amount of people who don't necessarily successfully connect peer-to-peer, we're enabling those use cases as well. So our connectivity rates are like 90-something% and above, which is really beneficial for if you want to build a real-world application. And that's it. Sorry, I think I took a little more time because we had some questions. But my name's Ankur again. Welcome here to our office. Glad to have you guys here. Looking forward to the rest of the presentations. And that's it.
Question. Do you provide a server
Absolutely. So on top of all the features you just heard about, none of the media streaming ever has to go through any hardware that you guys have to provision and rent, whatever it may be. We have our own infrastructure. There are things that you can do as an application developer to sort of call into APIs that we have on the server, like a RESTful API, like getting the archives as an example. But you never have to worry about the media and the bandwidth to transfer any of that.
Can I do my own server?
Like an on-premise solution. We don't have an on-premise solution. It's something that I know that our product team's thought about. We kind of believe in like the cloud-based infrastructure. And there might be some use cases where it could be valuable. I'm sure the product team is willing to have that conversation.
So the only thing you'd be doing is doing the connecting.
But no, the server, I mean, there's a lot of moving parts in the server. There's different processes for handling signaling and handling the routing of the media and for recording of the media. And there are some moving parts.
Does the media always pass through your media server, or sometimes the media goes directly to P2P?
Sometimes it goes directly to P2P. And you as a developer elect, do I want a relayed session, which in our API that means try to connect P2P and at worst fall back to turn. That's what relayed are. And then do I want a routed session, which is the one that I have the diagram with the blue dot.
My understanding was that term was maybe a firewall traversal thing, was the media servers where they would be looking for the scalability, the number of people who would happen, right?
So you can think of stun as basically just firewall traversal. It's sort of a reflexive way to get the outside IP address of that network, so that hopefully they can route the stream into the actual client that's trying to. But there are some networks, like ones that have symmetric NAT on them, where there'll never be a way to do that with just reflexive lookup. So you do relay the media through a turn
I
server.
mean, the term and the media server, the main difference is the term is going to be a one-to-one, whereas the media server can be a one-to-many. Is that correct?
Yes. What I'm trying to say is, even with a relayed session, you could choose to post your 4-person multi-parties chat over just relayed and just have it go return. That's totally up to you. But there are lots of advantages of going routed, things like archiving, things like the intelligent sort of fallback controls that we get at the media server, the algorithms that we can run. So it's really up to you. We want to give maximum flexibility.
Can you seamlessly transition a session from peer-to-peer to routing to your media server?
That's a cool idea, though. Okay, thanks. Sorry, I don't want to take any more time.
I have just a question for you, just to know if what is the level of knowledge you have today on WebRTC? Are you more interested in the developer part or the solution part? What is your both?
Who's built the WebRTC app before? Okay.
We use the data channel API. Okay.
That's a good transition, right?
Yeah. Who knows? Who knows what CDN is? That's easy. Okay. So I'm going to share some of our experience with building peer-to-peer CDN. And my name is Hadar, and I'm from Peer 5. And we built the peer-to-peer CDN using WebRTC, using the data channel API. And we like this guy, actually. We found out about him just recently, and I think he explains exactly what we're doing. So this guy is having a lot of fun, and that's exactly the way that we like to think about it. People can help each other to experience things. So crowd surfing is a very physical experience, but our idea is that if we all watch content online, it's the same content. Why should we all use the servers that are in some other city or some country and actually help each other? And we're not inventing it, actually. Obviously, WebTorrent and other great technologies have been there for years, and they've shown to be very, very effective. But we're taking it to the extreme here by using WebRTC and building it for the web. And I'm going to talk about some of the challenges doing that. So let's start. Sorry. Okay, so why do we think that CDNs are not enough? So CDNs are fine, great technology, and many years of development were spent there, but it's not very scalable. So as we grow, as we move to 4K resolutions, as we companies, content providers go to other countries, and they're just going to use more and more servers, and it's not good. Peer-to-peer can be actually faster, lower latency, with higher throughput. It is cheaper, and there's no other choice. Again, because there's just not enough capacity, and we're now seeing these problems more and more. So this is a recent example of the World Cup, of the finals of cricket World Cup, and India won, and they beat Pakistan, and that was just in February this year. And 25 million people watched that live streaming, 6-hour live streaming online. That was a big event, amazing results. The performance was okay. Some people reported it didn't work that well. But it was huge. It was a record. But the thing is that 1 billion people watch it over the television. So just to give you a perspective on where we are today with live streaming online and where we need to go when these people are going to consume the content online. So that's what we're trying to solve. And if we compare CDN with peer-to-peer, CDNs, they have many advantages. They work very well in the web. So as you load a web page, you can instantly grab content from the CDN, just to do DNS resolutions or TLS handshakes, but typically under 100 milliseconds, you can start getting even video. And they're very reliable, they're very predictable. But the problem is that they're expensive and you need to plan your capacity. If you're now working with an audience of 1,000 users on average, and you go viral because you build such a great service, and now you have 10 million people, and it's going to be super expensive and may not work as well as it worked with the 1,000 users. Peer-to-peer, on the other hand, it is very scalable. It is free. Question is free for who? But generally, you can say it's free. It's very, very fast. The challenge is that it's not as reliable. You don't know. So our product uses a mesh network. So you're connected to the mesh network, various peers, and to the server. And this is like the typical architecture of these products. And when these users come, we don't know exactly what is the throughput, what is their session length. They can live in any second. If you think about it, it's very, very unreliable. Another interesting thing in WebRTC that we have slow start. And when I say slow start, I mean that before any peer-to-peer communication can happen in the web, and that's not only for the data channels, but also for Tokbox or any WebRTC application. There needs to be a few things that happens before that. So the JavaScript needs to be delivered to the end user, first of all. Before that, nothing can happen. And then we need to communicate with the signaling server. Then we need to discover these peers. And once we discover these peers, then we use the signaling server, we do NAT traversal, and only then we can start communicating. So a lot has to happen before we can actually get Weiss from other peers. So it's not easy. It's hard to control and to manage, and there's a lot of work for us here. Also, these guys from PeerCDN probably know what I'm talking about, and let's see what we can do to solve it. So actually, we don't have to choose one thing. We can use both CDNs and peer-to-peer, both HTTP and peer-to-peer at the same time. It adds more complexity to that. Now we need to do some smart switching but it's great because we can enjoy both predictability of the servers and very fast start, and it's more scalable because we can use other peers at the same time. The challenge is to build switching protocol that knows intelligently how to fetch the exact pieces of content from the peers while using the servers at the most critical times. And to encapsulate it, when we build this solution, we want to give you guys, when you develop a web application, you expect something like a CDN. It needs to be super simple and to hide all this complexity. There are more issues, I'm going to talk about it in a second. But the architecture, again, this is very friendly, simple way to see that. But so this is a mesh network of different devices. They are connected, and we are in charge of deciding who is going to communicate with each other users based on many different factors. But it's important to understand that the session typically begins with the CDN. So if you think about live streaming or video streaming in general, the first video segments are going to be received from the server, and then we're going to switch to peers if we can. Okay, why the web is so special here, and WebRTC is so important. No one is installing it. So there were a few products in the past that did great peer-to-peer technologies, but they require the end users to install. It's not something that is going to happen. Like from 2008, actually, it was very obvious that no one is going to install plugins or configure their machines just to watch videos. Since YouTube became so popular, everybody expects flawless experience, and WebRTC is so much important here to let it work without any hassle from the end user. The other thing is, yeah, as I said, very fast experiences. Nobody wants to wait. So if you think about it, WebTorrent, for instance, it's a protocol that is fully distributed, and it uses DHT and all sorts of intelligent methods to exchange metadata, but the penalty that it takes time for each user to discover other users and to become very, very efficient. On the web, on mobile, the sessions are very, very short. So we chose a centralized architecture that immediately directs the end users to communicate with each other with more metadata, and needs to be super effective from the first second. And the key point here again with WebRTC is that it was not possible without WebRTC. Okay, so a few words about WebRTC, and I think we can go over it pretty quickly. What I like to tell is, I think people don't realize it, how much money was spent on WebRTC, and we just got it for free. So Google bought two companies for a lot of money back in 2010, and simply open sourced the code. So this is why WebRTC is so powerful, so much, and the efforts on the industry were so big, and now we can just use it. So good for us. And specifically, if you think about the data channels API, it's very, very cool because it's a new stack. This is the stack that we know from traditional web programming, TCP, and sometimes it's TLS. We lay over HTTP. We now have things like WebSockets. It's great. We can communicate fairly easily with any server. But now we have a much more interesting stack on top of UDP. So we can communicate not necessarily reliably, and not necessarily in order. So if you're developing a game, something like that, you don't have to stick with TCP. You can enjoy the benefits of UDP. For instance, if I'm developing a game and I want to update the other opponents or the other opponents about my location, and the connection is not that very reliable, I can decide that I want to try it for 3 times, retransmit the packet 3 times, but then if there are failures, I will just stop because I'm going to update on the new location. So we can build stuff that will not be, with TCP are just not possible. So there's a whole stack. I recommend reading it and reading it. Obviously, ICE is involved and all sorts of technology that lets us make this peer-to-peer communication.
How do you qualify the WebRTC channel resilience, or does the single word qualify the comparison between the TCP that with the TCP?
From how do you compare this?
Yeah, it's resilience. Where is the
I think flexible. To me, it's flexible because you can send packets unordered and unreliable. Lets you build more powerful real-time applications. And the throughput and the latency are better, I think that's said, because it's UDP.
For some things like first-person shooters, you need UDP to have actual usable performance.
Right.
So it wasn't possible to do multiplayer, peer-to-peer, first-person shooters before.
Thank you. Okay, so we need to mix them together. And let's keep that directly. Okay, sorry about that. So how does it work together? This is the architecture. I think it's very typical. I'm sure PeerCDN will be very similar. So the Pure5.js is our client-side logic. Every end user gets that. It is delivered using a standard CDN and we use Cloudflare just to deliver our client-side logic. Once the client got Pure5.js and is loaded, it communicates with our backend tracker, and we also have, as any other WebRTC service, signaling guides, everything that is needed to connect between 2 users. The tracker also, of course, has the logic to tell the users, okay, you should talk to this guy, he has the pieces that you need. Start communicating, and actually you should ask for this piece because you're going to need it in a second. And this is the centralization part of this system that is crucial for web experience. That's why once I load the Pure5.js, I can immediately receive metadata about the network and start communicating immediately with other users and receive bytes. Okay, so this is a little bit, who knows what is HLS here? Okay. How much time we have? Maybe we can stand for. So HTTP live streaming. This is the most popular live streaming protocol today on the internet. It's now being replaced to some extent by Dash, which is part of endpoint consumption. But let's dive in on how live streaming works. So how do we use the server and peers at the same time for video, especially live video? At the beginning, it was like science fiction for us, but we realized live streaming today on the internet is just a set of files that are being delivered by the CDN. So what we can do is that we can replace some of the calls to the server with fetch from other users. And this is like a typical buffer that an end user would have. At the beginning, the critical part is going to be fetched mostly from the server. So these are the gray box. After we receive 10 seconds, this is configurable, of course, and we start to fetch more content from the peers. And we try to be in a safe zone where every new piece of the content is being delivered us from the peers. So it's easier than what you imagine because it's all files in the end. But there are some challenges in making it very, very efficient. Okay, so just a word on video on demand. On video on demand, the algorithms are a bit different because it's a big chunk of video and it's all known from advanced. You need to do things like 50-50 algorithm where you fetch the rarest first pieces that are not very close to your location on the stream. But I want to talk more about live streaming. It's very, very difficult to build high-efficient live streaming peer-to-peer networks because there's not a lot of content that you can send to other users. You only have the latest content that you got in play, but you also need to share it. And there's a lot of waste because we try to optimize and receive as much content as possible from the peers, but the content needs to be played, so at the same time we have to take it from the server. So the mix thing was very difficult. And one cool thing that we did was switching a little bit from this topology, where everybody can potentially be connected to everybody, to here, but we're not an overlay tree topology. We effectively built something similar, and I explained why. So what we did is that there are different offsets in the live stream, and the strongest users are going to be closer to the origin. They're going to receive the bytes from the CDN, and the strongest users are going to deliver the bytes to the next level. And in the end, the people with the highest delay to the live stream are typically mobile users or users that cannot effectively upload to other users. So, and it really, really affected the results, and you can get higher efficiencies that way. And yeah, so about the peer selection, we base our algorithm on it's all on the server side. Sorry, it's mostly on the server side. The peers are independent in terms of what actual chance you're going to ask from other users. But the decision on who am I going to communicate with is on the server, and it is based on the block availability. Like, am I going to talk with Feross? Maybe the box that I need. If he doesn't have any content to contribute to me, I'm not going to communicate with him. The network availability, the ISP, and geography also affects us, and there are more parameters that we use. So this is like a new case study that we did to reach 95% peer efficiency. It means that 95% peak was 95% of the bytes were delivered from the peer network versus the server. So effectively, if you're running a few servers, like let's say you have 4 servers, with us you can think about it as if you have 8 servers because we multiplied by 20. And this is like typical this is real data from the customer that the blue lines are, the blue bars are peer-to-peer consumption, the green lines are HTTP consumption. And you can see how the spikes are dramatically reduced because the more users there are, the more peer-to-peer we will see. So it's very much diminished. Okay, I think that's about it. We're building the largest CDN right now. It's very exciting, and because we don't need to buy any servers, it's very easy for us to scale and build a network. And that's the idea. I really like this guy, so I'm sorry for using him all the time. Any questions?
So I thought you described it as being a hybrid, having some CDN, so I would assume there are some servers.
Sorry,
I would assume there are still some servers at the top.
Okay, yeah, so the servers are either third party, like someone can come with Akamai and will work on top of Akamai, or it can be just the data center, so the origin servers. But we're not operating any servers, so no data. Yeah.
So who are your customers? Who use your services?
And we have sports channels, we have on-demand animation, mostly video.
In HLS case, there is the problem of the update of the table of content with the chunks, right? That happen every 10 seconds. There is a table of contents, right, that gives you for each of the chunks different file name with different resolution that allows you to cope with the bandwidth. So you don't have 30 seconds ahead of you of visibility on the files.
Typically you do have, so the playlist, the average that we see 30 seconds, can be 10 seconds as well, but usually you do have visibility for about 30 seconds.
Okay. So
sometimes you have more.
Okay. It's different for planning if you don't know which file going to be available.
So so typically players ask this playlist every 5 seconds, and then they see the next 30 seconds of the segment.
What's the capacity for a single session? Signaling and arrange all those peers together.
What's the capacity of?
For your signaling session, you still need to arrange all your peers together. So how large can you scale there?
Yeah, good question. So, like, how many users can one server handle? Okay, so let's see what I can say. Okay, so I can tell you that a single server today can handle around 10,000 confirmed users.
So you think bottleneck is a tracker, right?
Yeah, but it's very, very, very scalable. We use now we use a Google Compute Engine, so we can just spin off more.
Right. Maybe rephrase the question. Is you playing bottleneck the tracker or the signaling server?
It's the tracker. Any other questions?
How long does it take to get like multiple browsers essentially to put on installation?
Once they are already after the signaling, in JavaScript context or just in the network?
Total system. Like, do you see like the first 100 can fast, the rest is slow down? It's way too long.
No. Why would you say? No. It's not very easy to measure it because we don't have the full visibility of the. Like, yeah, we can measure it on the output. We don't know exactly what happens. I can show a demo. I can show one. Actually, I wanted to show. Maybe I can show some code. Okay. Or not. I don't have it open now. But I'll show you. I'll try it in a second. You can see it online actually. On peerfile.com, we have now many demos, many applications, many examples. Okay. Thank you. Oh, okay.
Does your selection take into account network locality?
Yes.
And how do you determine that?
So we take into account. Let's go here. Yeah, so ISP, geo.
It's all from IP.
Yes. We're experimenting other parameters as well. What are you specifically aiming for? What? Maybe you have new ideas.
I'm just curious.
Yeah. Yeah. So actually, we found out that Geo and ISP are not extremely important here because it's a mixed environment where you use multiple peers and you also use the server. So it's not that a single connection is so critical. You see what I mean? So we don't necessarily need to use the lowest latency connections available. That's not the #1 factor. We want it to be high throughput, and more importantly, we want to pick people that have pieces that no one else has. That's like most important.
The topology of the connection, you take that into account, right? When you make that tree, you balance the short based on that. Right?
Yes.
So that's more important for the topology of the connection than it is for single access.
Right. True. Yes.
As a developer, if I want to put peers 5 on the website, is there something special about assets that I want to serve over peer 5? Or does your JS have to belong to the head methods queue right away to figure out all the assets that are going to be built? How do I sort of let you know what assets are going to be built?
So it's explicit. You tell us what you want to do. And it's not very good for general purpose websites because of the slow start problem. You probably, if you want the Tokbox homepage, probably going to be served better from Cloudflare than Peer 5 because it will take us some time to, to initialize.
Yeah. So do I invoke the Peer 5 library to tell you, hey, now I want everything, and then give me this is everything I need?
Yeah. So actually, I wanted to show the code for the video player. So we have now plugins for various video players like JS and JW Player. So you can put just another line of plugin JavaScript next to the player JavaScript, and it will just work. When the player initiates, it will just use us. With images, you have to explicitly, in our API, put an attribute on the image that you want us to load it. And it works well for image galleries, but we don't recommend it for just home pages.
Sure. Cool. Thanks.
Yes, thank you. All right, thanks a lot.
That's nice. That actually looks good from the first try. Amazing. It's never happened. Hey everyone. Can I start?
Yeah, sure.
Oh, cool. Hi. So I'm Feross, and I want to talk to you guys today about WebRTC everywhere. This idea that you can run WebRTC on all sorts of devices and in places. So, servers, mobile devices, and obviously web browsers, and even desktop native apps. And this unlocks a lot of powerful capabilities. So, really, another way of saying this is WebRTC beyond the browser, right? When we think of WebRTC, we usually think of just browser use cases, peer-to-peer CDNs, or video chat. But there's really a lot more you can do with WebRTC, as I've discovered in the last few years of playing around with it. So, this is just background on me, I guess. I already said my name's Feross. This is the project that I've been working on for the last year and a half. It's called WebTorrent. And the idea is to build a BitTorrent client that works in the browser. So a true peer-to-peer implementation. So not something that uses a central server or a proxy or anything like that. Every few months, I see a site pop up on Hacker News claiming to be BitTorrent in the browser, but it's usually just making XHR requests, or a WebSocket has a WebSocket to some server that's actually torrenting the file that the user wants. And of course, the minute that site gets onto Hacker News, their server dies. So cool hack, not the right solution to the problem. So WebTorrent, like others have said, it's nice because it doesn't require an installation. So it should be easier for people to use than the typical BitTorrent client that you need to install. You should be able to send a link to somebody and say, check this out, check this content out, and it should download peer-to-peer. It's kind of similar to Peer5 in a sense. Before I did WebTorrent, I worked on a company called PeerCDN, which was very similar to Peer5. I'm not working on it anymore. We sold it to Yahoo and they shut it down. So, but I'm doing WebTorrent now, which has kind of a different goal than Peer5 or PeerCDN. And the idea is kind of to follow the BitTorrent protocol as closely as possible, because if we do that, and we only make changes to it in the areas which are necessary to support WebRTC, then we can get the existing BitTorrent clients that are out there to adopt WebTorrent. And what that means is then they can talk to the web browsers that are out there, right? So typical clients use TCP and UDP, or UTP really, but it's just UDP basically. And obviously that doesn't work in a browser because of security issues. So the only option we have, the only transport, peer-to-peer transport that works in the browser is WebRTC. So we can do browsers can talk to each other all day long, but this isn't gonna let us access all the content that's out there already and all these millions of people who are running torrent clients unless those clients make a change. So I have a picture that kind of demonstrates this idea. Looks something like this. Yeah. Can you guys all see that? Yeah. So, these are pure browser WebTorrent clients. It's just a JavaScript file on the page. It's a nice little API. You can tell what torrent you want to download, and then these can talk to each other. They can talk to hybrid clients, which are installed apps that can speak to both networks, the normal one and the WebRTC network. And then there's all the ones out there that don't have support. So this is kind of what the topology would look like. And ideally, we'll have as many hybrid as possible. That's my goal. So, what was the other thing? Oh yeah, so there's some other nice features like, if you use it in, so the thing that's really cool about WebTorrent is it's actually, since it's written in JavaScript, the same code works in Node and in the browser. There's only a few areas where we do something different depending on the transport, but like 90%, 95% of the code is reused. So all that logic for, picking pieces, it's an entire torrent client, it's pretty large, and most of that code is exactly the same in both places. And it's actually the same NPM module even. You can just NPM install WebTorrent, and you can use that code on the client or in the servers. It's really neat. So if you use it in Node, you get some nice features like you can send it to your Chromecast or to AirPlay or VLC or whatever. And in the browser, you can stream it into a video tag or an audio tag. The code is really simple. This is kind of what it looks like to get a torrent to play into a video tag in the browser. You just require the library. If you don't use Browserify or something like that, then you can also just include a script tag on the page. How many of you guys have heard of Browserify or used Browserify? Okay, cool. It's awesome. It lets you use nodes that require in the browser. And then, we add the magnet link we want to download. We get a callback once we have the metadata information about what files are in that torrent, and then we just iterate over the files and just make a video tag for each one in this case. And there could be multiple videos, and then we just append that video tag to the page and start streaming the content into the video tag. And this uses media source, which can actually take data from JavaScript and hand it to the video tag and say, please play this as the data comes in. So you can start to play the video back before you even have the whole video. It's really cool. Now, I haven't worked on this alone. There's a bunch of people who've helped me, whose names are here. It's an MIT license open source project, so there's a lot of people involved. So enough about WebTorrent. Really, like what's interesting about WebTorrent, in my opinion, is it's based on WebRTC. So it's actually true peer-to-peer. So it actually puts power back to the people, in the hands of people. I mean, when the internet was first created, we had a lot more of a diversity of services, a lot more of a decentralized topology for the way the internet was built. And with the web, we have this it's kind of designed to be server client, where you have this weaker client, and it's dependent on a server to do anything. But fortunately, that's changing with WebRTC and with a bunch of other technologies that are coming out, like service workers, which actually lets you offline an entire web app, and then you can go back to that URL, and that app is cached forever, even if the server's gone, which is really powerful. So this is changing, and this is going to enable us to build apps that respect the user's freedom and really respect the user's rights. And it's true personal computing, I think. So that's why it's exciting to me. And another thing I thought was, I actually think WebRTC is a backdoor, like, because the standards people who are coming up with this aren't doing it because they care. I mean, maybe they care about freedom. I don't want to judge their motivations, but they just wanted video chat to work. They just want to make Google Hangouts or whatever, Skype in the browser. But whoa. Now it's more dramatic. This is the dramatic part. Get ready.
This is normal. This is normal. Don't worry. They come back on in like 50 seconds.
Oh shit, they're shutting you down. This message can't be spread. Yeah. So really what WebRTC is, it's building peer-to-peer into the fabric of the web. I mean, this is an API that's built into every browser now, right? So it's actually a great opportunity to kind of try to change the architecture of where apps are built, if we want to, if we think this is a good idea. So in particular, the part that's interesting is the data channel. Like Hadar was saying, Peer 5 is built on the data channel. This lets you send whatever data you want to peers. It's basically like a socket, like a web socket. The video and audio parts are very prescriptive in how they work. So really, we want to build our own protocols on top of this transport, this data channel transport. So there's already been a whole bunch of innovation and things that the standards people didn't expect that have already been built with the data channel, like peer-assisted delivery in the browser. We have file transfer apps where you can send files to someone who's sitting next to you or across the world or whatever, and it'll stream the file across directly peer-to-peer. You don't need Dropbox. You don't need to wait for an hour for that 5 gig file to upload before you can get the share link. It just starts to go right away. You can host entire sites like this. It's not a good idea because you don't want to load your JavaScript and your HTML and stuff from peers necessarily if you care about performance, but you can do it. And then there's all kinds of other apps. And I actually think we should just, if you're building a new protocol, like if you're building, you're the next person who's going to build BitTorrent or Bitcoin or one of these kinds of true peer-to-peer protocols where everyone talks to each other, you really should be thinking about building it on WebRTC, because then you can include browsers in that network of clients, right? So right now, if you have a Bitcoin client on your computer, you can only talk to other people who have Bitcoin clients on their computers. But if it was built on top of WebRTC, then those desktop clients could still talk to each other, but they could also talk to browsers, right? So that's the power of it. So yeah, WebRTC beyond the browser. So I want to give you an example of this WebRTC beyond the browser with WebTorrent. So hopefully this all works. This is going to be a lot of moving parts. Okay, wish me luck. Okay, so first thing I want to show you guys is where is it? Here we go. Okay, so this is a video player called Playback, which this really awesome hacker made. It's kind of like VLC. You can play stuff, but it also supports playing YouTube videos. You can stream to your Chromecast, and it can even play YouTube videos. So it's pretty cool. And the best feature of all, you can actually drop a torrent file. This is a Creative Commons licensed movie, for the record. I can drop it right onto this to this player, and assuming that everything, what the heck happened to it? Oh yeah, sorry. I think this is there's no seeders right now. Give me a moment. Okay. Sorry, I just needed to make sure it's seeding. Let me try that again. Okay. So where did it go? One more time. Okay, so here we go. So this is the player. I'm gonna go to that torrent file, drop it on there. I'm running. I'm the only seeder for this, so that's why I needed to do that. There we go. So now movie's playing. So that's the video player just playing a torrent file. Cool. It's just getting it from another peer, and it's using the DHT. The torrent file, yeah. You have the torrent file. You can also paste a magnet link in. So it's just playing it right away. It's fetching the pieces of the torrent sequentially, so it can play back right away. That's pretty cool. So this is kind of the same technique that Popcorn Time uses, but it's I'm not affiliated with that. It's the same idea. And this is talking to the normal network, right? The normal BitTorrent network to get this, but we can actually go to this website here. Where is it? Somewhere. Let me just go to it in a new tab. So this site here is a demo site I've made to demonstrate WebTorrent. So it just lets you paste in the hash of the torrent, and it will connect to whatever web peers have it and start to download it. You can also drop a torrent file right onto the page. So let's do that. Let's take that same torrent file and drop it right onto here. And it should start to play back right away. So now you know what? Notice how fast the download is. It's like 6 megabytes a second. So that's because I'm downloading it in that video player, which is running on my own machine, right? And that video player can talk to both the normal BitTorrent network and the web network. So it's actually seeding it to this browser. So it's a desktop app talking to a browser, and it's streaming me the movie. You can see it's already 40% downloaded. And check this out. Even though it's not all downloaded, I should be able to actually seek. I think it's actually pegging my CPU because it's downloading so much faster than it normally does. It's actually, let's see if the seek bar comes up. Anyway, in general, you can seek and reprioritize dynamically, which is another cool feature. Okay, cool. One other thing we can do, I can actually drop another type of file. Let's drop like a, I don't know, cat picture or something onto the same page here. I'll start to see this cat. Okay, cool. And I'll copy the hash. And now check this out. We're going to go to another entirely other website here. This is just let's me live code. And let's actually write some JavaScript to fetch that cat picture. So I'm seeding that picture over here. You see I dropped it onto the page. Because I did that, I'm now sharing it with whoever wants it. I got the hash here. So now all we need to do is actually just write a little bit of code to fetch it. So I can require WebTorrent. Let's create a new client. Can you guys all see that? Is that better? Okay. I'm going to create a new WebTorrent instance. Really straightforward. And then I'm going to add a new torrent. Let's put it in a variable. Let's call it torrent hash. Okay, so now what this is for is just going to get it out of the way here. Cool, so this callback gets called once the JavaScript on the page has fetched the basic information about the torrent. So we're starting off with almost nothing about it, right? This is basically a magnet link, right? Have you ever seen magnet links? They're really succinct and short. It's basically just a hash and a couple of other pieces of information like a name or a friendly name to show and some trackers, which are not necessary. This is all you need to download a torrent, that little string. So we're just going to pass that in, and then it's going to go out and it's going to use trackers. Currently, it just uses trackers, and it's going to find all the peers out there, and it's going to ask them for information about the torrent. And once it has the basic info, like all the files that are in it, then it's going to call this callback here. And then we can look at the file names that are in there, like this. We just go torrent.files, and let's just iterate over them. Actually, we know there's only going to be one, right? The cat, it's the cat. So let's just do this. Let's just do 0. We know that there's only going to be one file, right? And we're going to call get blob URL. So we can show this cat picture in the page. So it's going to call us back with a URL once we have the cat picture. So if there's an error, whatever, we'll throw it. If otherwise, we can create an image, document.createElement, image, image.source equals the URL that we got from the callback, and then let's add it to the page, document.append, or document.body.append child image. Okay, what's wrong? Am I missing something somewhere? No, I'm not missing semicolons. Let's see.
We should come out.
Where is it? Anyone see the problem? Come on, guys, help me, help me, help me. What is going on? What's the problem? Torrent hash, function torrent, files, get blob URL, function. I'm missing a parentheses. Sorry. What the heck? So this is good, right? This part so far? That's correct. What's wrong? Why doesn't like that even? Well, actually, I have some working code over here. I'll just use that. It's basically the same. Yeah, it's almost exactly the same. I don't know what the problem is. Let me look at that one more time. Add the torrent hash, get the callback, look at the first file, call this function, pass it in. Come on. Okay, whatever. I'm going to use the other code. I don't know why. Actually, let me just try clicking run. Maybe it's just the syntax highlighting sucks. No. Oh no, it did work. It's the syntax highlighting is broken. Okay, whatever. Oh, probably because of the semicolons. All right, whatever. So you see how fast I got the file when I push run, right? We can try it with another file just to see that it works. Let's the movie's still playing. Let's just refresh this. Grab a different picture, maybe different cat. Grab that hash. Go over here. Change the hash. Run the code. Get the different cat. Right there we go. So we're torrenting in the browser. Woo. Thank you. So WebRTC is universal. If you build your protocols on top of WebRTC, you need to have a divide between browsers and between native apps. And I don't know how. So I guess there's a variety of experiences in here, but really quickly, I'm just going to list off some of the things I really like about WebRTC that make it a good transport to build your protocols on top of. So one is you get NAT traversal for free, right? Think about when Skype was doing their first client, they had to spend years just getting Skype users to be able to talk to each other and figure out all that NAT traversal stuff. WebRTC just includes that, right? So it does stun and turn. It does the whole ICE thing for you. Really nice. So for your desktop app, you should use it too. There's no reason not to, or even for your server app. If you want to talk to another server, just use WebRTC. There's no cross-origin policy. So did you notice that I was seeding the file from Instant.io, right, and also from a desktop client at another point in time, and I was downloading it from Requirement, right? Different domains, doesn't matter, no problem. They can talk to each other. The security assumption there is that if the two pages in the different domains include the JavaScript to coordinate the peers to find each other and talk to each other, they probably want to talk. They probably are cool with it. So don't worry about it. There's no same origin. There's no cross-origin policy. Wait, sorry, same origin policy. I didn't mean to say cross-origin. Same origin. There's also no permission prompt to do data channels, so you can just do it. So you don't have to ask the user in the browser. That's pretty cool. Again, the assumption is you can already generate garbage data and upload it to a server and waste all their bandwidth if you want to. So WebRTC doesn't enable any kind of new attack there. You get mandatory encryption on the transport, and the API is really easy. It's actually just like a WebSocket. So you got send, you got a message. When you get messages, that's it, right? That's it. It's really nice. So how do you actually use WebRTC in all these places today? So obviously in the browser, we got a lot of good support in Chrome, Firefox, Opera, Edge, Microsoft Edge. The next version of IE is going to add it. Safari, who knows? Desktop apps, we have a lot of really good choices. So for a long time, the way people would do it is they would compile in the WebRTC.org library. That's the Google project. It's like C++ code for the WebRTC library. But it's kind of, I don't know, it's harder than it needs to be. But what I really like to do now is use Electron, which is formerly Atom Shell. And that's just a Chromium-based native app builder thing. So you can build your native apps in JavaScript, HTML, CSS, right? Build it like a web app, but it's a native app. That's actually what Playback was using. So Playback, this is actually a JavaScript, HTML, CSS native app. It's running on my computer, right? But it was built with web technologies. So it's cool because it comes with WebRTC built in, since it's using Chromium, right? So you just get WebRTC. You don't have to compile anything. You just use it. You just use the JavaScript API, and you got it. You can also use Node-WebKit if you want. But Electron is great. I went up to Portland like a month ago and hung out with Max Ogden and a couple of other Portland hackers. And we were able to build a clone of Slack that uses peer-to-peer in 3 days. So it had like support for markdowns and emojis, and you can create your own room. And we even started building actually a way for you to connect to people who are sitting within the vicinity of you, just using Bluetooth. So you can actually talk over Bluetooth without pairing. So if you're just sitting next to someone, you just like connect, and then you're in the same room, right? And it used replication, so there was no servers at all. It was, no one's using it right now, but it was really cool, and people were using it for a few weeks after we made it. You can actually see it running right here. It's kind of lonely right now. I cleared my database, and I'm talking to myself. But it is a pretty full feature. You can create your own channels, and you can ban users and block them. You mark down whatever. You get the idea. You can even run it. There's no persistence. Yes, there is. So as long as somebody has, as long as somebody is online and in a room, they have the entire history of that room. And as soon as someone else joins, they use a replication protocol where they figure out what they each have. So let's say I went offline an hour ago, I don't have last hour of messages. We can very efficiently figure out what messages we each have that the other guy doesn't have, and we share them with each other. So, and it's actually done securely. So you can't make up that someone else said something, because we probably broke a bunch of crypto rules about what you should and shouldn't do. But as soon as we boot up the app, we figured out who you are by looking at your GitHub, your Git config file. We found your email address in there. We look you up on GitHub, and then GitHub actually has an endpoint where you can list out all of your public keys on GitHub, right? And so then we do is anytime you send a message, you sign it with your SSH private key, and then anyone who receives it looks you up on GitHub and lists out your public keys and verifies that the message is actually from you. So if it's from you, you get the little green check next to your name. You see that right there next to my name. And if someone that didn't check out, right, then it would say allegedly Feross. Feross. So it was, you're not supposed to use SSH keys for these purposes, so we probably shouldn't have done that, but like we should change it to use something else, but it was cool. I think so, yeah. It's the same. It's only for desktop as far as I know, so not mobile, just like Windows and that.
Is that a screenshot?
No, this is a real app. Like I can send it
right now. Is there a reason why we can find each other?
You know, I think that maybe so there is one point of sense. Okay, let me just. I was going to talk about this in another slide, but I'll just talk about it now since you brought this up. There's a server that introduces the peers to each other. That's the only point of centralization here, right? The server doesn't know who's talking about what, but it has to introduce you so it knows what room you're in, right? That's probably down right now because it was made a month ago, and I don't remember who's running the server. Okay. I know. I just typed this to myself. I can send messages, and it's in my local history, right? And the next time someone connects, they'll get my message. Anyway, but this is actually an interesting point. So we really need to eliminate the server, really, to make these apps more truly decentralized. In order to do that, we need a WebRTC distributed hash table, or DHT, like BitTorrent uses for peers to find each other. So in BitTorrent, using modern client, as soon as you boot up the client, it needs one peer. It just needs to find one peer somehow, right? So once it has one peer, it never needs to talk to a server ever again. So the way it gets the first peer usually is it hard codes in a couple of different servers that just have a list of peers that are they're out there. They know like there's they have 10,000 IP addresses and ports. They just give you 100 when you ask it. But if you really had to, you could type in an IP and port, and then you never need a server again. And also when you shut down the client and boot it up tomorrow, it saves the whole list of IPs and ports of people you've ever talked to, and it just iterates through them in hopes that some of them are still online to connect. What? The supernodes. There's three main ones that I've seen in most of the clients. There's one run by Transmission, uTorrent, and BitTorrent. And now uTorrent is owned by BitTorrent, so two are run by the BitTorrent name. But yeah. But so that's what we want to get to. Like, I think it would be cool if we didn't need these trackers introducing peers, because what you can do is, if I'm connected to John, and John's connected to someone else that I want to talk to, I can ask John to introduce me to that person. And then John is the signaling server. I give my offer to John, he passes it along, and then they give their answer to John, he gives it to me. So you don't even need a server, right? But then you need to manage the topology of how this works. So I haven't really spent too much time doing it, but I've done some back-end little math. It's going to be hard. John's actually really interested. He might work on it. But there's another guy who worked on a similar idea, but nothing has really been robust and good enough to really use. But if this problem is solved, it would be great. Okay. How much time do I have?
How do you
almost over?
implement this without
Oh, what?
how do you implement
Oh, peer-to-peer? Well, so once I get connected to some peer out there, I use a server, and let's say I use a server, it introduces me to you, via the signaling process. Now I'm connected to you with the connection. I can now talk to anyone you're connected to if I ask you to introduce me to them.
client side JavaScript?
client-side JavaScript. There's no plugin yet. We have a socket to each other. You have sockets to some other people. I can ask you to forward stuff to them, and they forward stuff back to me, and then we redirect it. Yeah. How much time am I? Am I almost done?
Well, to 5?
Huh? 5? Okay, sure. If you want to support WebRTC in your mobile app, you have to. The best way is to compile Google's WebRTC.org library. They've done a lot of work to make it compile really easily on iOS. And some challenges of some challenges I guess for building everything on top of WebRTC. To be honest, because I want to be honest, like hyping in a lot, but there are some challenges. So one is most of these C++ implementations, like Google's library WebRTC.org, doesn't have a way to just compile the data channel part of WebRTC. So there's all this code for video and audio codec stuff. It's like hundreds of thousands of lines of code. And right now, there's no way to just say I want to compile just the data channel part. So it takes forever to compile, and it's big. So there's an issue. They want to fix that because they know there are people like me and others who want to just use the data channel, and they're going to fix that. But for now, if you do use that library, it's a huge compilation. The connections aren't as lightweight as TCP and UDP, and I don't think they won't ever be because there's this offer answer exchange you have to do, and it's a different model. So there's no IE and Safari support yet, but there is a Temasys plugin you can use, a plugin you can install in Safari and in IE to get support for WebRTC. So even though the whole point of WebRTC is to not need plugins, you can get a plugin in those browsers to get support if you want. Okay, so I touched on this several times before, but just to reiterate, WebRTC is not like TCP and UDP. With TCP and UDP, if I know your IP address and your port, I can connect to you if you're listening on that port, right? It's like calling a phone number or sending somebody a letter in the mail. You just have to know their identifier, their phone number or their address, and then you can send them stuff, right? And they'll get it. They don't even have to ask them for permission. You can just send them stuff. But WebRTC is like getting set up on a date or introduced to somebody. You have to know someone who knows them. So in most apps, most WebRTC apps, we use a central server for this purpose. So everyone just talks to the server, and the server knows everybody, right? But what I said before is we can also kind of use our own peer-to-peer structure. I can ask you to introduce me to someone you know, but you do need that introduction. So it's a different connection model. And despite all this, there are still single points of failure. So in the browser, you need a domain name to serve your app, right? Your domain name can go down. This is not as robust as it could be, but we can use service workers to help with that. And like I said, we need a DHT, a general purpose. Am I really blocking you? Have I been blocking you guys the whole time, standing in front of the, okay, good. Yeah, so we need a DHT to really solve the finding peer problem. Also, there's been some, I don't know how much of a concern this is, but in theory, so when you first connect, you talk to a stun server to help punch through the NAT. In theory, this can leak your privacy, because everyone kind of uses Google runs a stun server for everybody as a public service. So it could leak some information. I don't know what exactly. I need to look into that more, but in theory, it's a leak. Another theoretical privacy like WebRTC is any web page can actually query your local IPs now, because when I'm generating this offer, it contains all my IP addresses that you could possibly contact me on, including my local interfaces. So you could track someone across sites in theory, you get their local IP, you can figure out their network topology. So there's some issues with that. So the Tor browser bundle actually just disables WebRTC. But there's a solution. You can just say, if you care about privacy, don't list out local IPs, right? Just list out relay server IPs, and then you lose the peer-to-peer aspect, but like services like Hangouts and things can continue to work in Tor. So it's solvable. I don't want to go into that. Yeah, okay, so anyway, point is we should use WebRTC despite the challenges. We need more peer-to-peer apps. We need more peer-to-peer primitives so that people don't need to solve all these problems over and over. You can just drop in a library and, bam, you have a DHT or something, or bam, you have like, whatever. Yeah, and I really liked what Hadar said. This last slide in his talk where he showed kind of like how Uber is the largest taxi company, but they don't run any taxis, and like Airbnb is the biggest what do you call it, accommodations company, and they don't own any hotels. So with WebRTC, we can kind of build these really robust, scalable services with no infrastructure, right? And so I think we can actually start to see like things like maybe Peer 5, taking out Akamai, or like, the Friends app taking out Slack, hopefully. Probably not, but you know what I mean. Like you don't need any infrastructure, you don't need any money to build apps this way. So it's pretty powerful. So if you want to learn more about WebTorrent, you can go to WebTorrent.io, and that demo site we used, the sample WebTorrent client, is instant.io. Thanks a lot. One, but I haven't had coffee for a month. So
wow.
Yeah. I got sick of the flu and I couldn't have coffee while I was sick. So yeah. Why am I talking like that? That's your regular video. Am I talking really fast? Is that the only question? Seriously.
The second question is what application do you put along this technology? The application.
Oh, WebTorrent? Well, I mean, I'm hoping that people will consider using it to deliver video, same use case as Peer 5. It works really well for video. And then I also want people to, I really think actually the cooler use case is the Internet Archive. The Internet Archive is trying to archive the whole internet, right? But they have to do fundraise, they don't have money. They literally don't archive stuff because they don't have money. But if they just dropped in WebTorrent, then they could save on all those costs. If there's any content that feature on their homepage, they shouldn't have to pay anything or barely anything for that, because the peers should step in and do all that work, right? So that would allow them to archive more content. And then, I hope that they consider using it. In fact, I'm actually going to talk about it in the next couple weeks.
So you mentioned
oh, but that actually didn't use WebTorrent. That just used WebRTC.
Okay.
We could use WebTorrent for the attachments, like the videos and pictures you dropped in.
So I heard the episode of JavaScript Jabber where you came on. Awesome episode.
Oh, thank you.
It was JavaScript Jabber.
JavaScript Jabber, yeah.
Yeah, cool. You talked about how Facebook uses torrents for like updating all their servers.
Yeah.
Would this like kind of help to do that, like in a web, or could you expand on that a little bit?
Interesting. Yeah, so what you're talking about is that Facebook uses BitTorrent to push out new code changes, updates to their servers.
Yeah.
Because they actually compile these huge binaries. They take their whole PHP app and they compile it into an executable file, right? And then that could be like a couple gigs. And they want to push it out to all their servers at the same time. They have hundreds of servers, thousands of servers. And the torrent technology lets that initial build server that has that file not have to do all the work to send it out to like the thousands of servers, right? I don't know what the application is specifically for browsers. I mean, I can imagine it being used to ship like JavaScript code updates in the background or something. Let's say that they change their client-side JS or something, and they want to update it. And a lot of sites actually store their JS in local storage because they find that it's faster than the browser cache. Being wrote a paper about this. You download your JS once, and then you put it in the local storage. And the next time you pull it out of that, it's faster than the normal browser cache. So maybe you could do something like where you diff it, or you could update it over WebTorrent in the background. And then, but honestly, I don't think it's stretching the use case of WebTorrent. I think, unless I'm not being creative enough and there's something else I'm not thinking of.
What torrent makes do without turn?
So yeah, the default, when you just use it, there's no turn. If you want, remember when I did new WebTorrent, you can pass in an option there, and you can just say use this turn server or use this different stun server. By default, it uses Google's stun server. Yeah, you can use it if you want. You don't have to. So for torrents, like it doesn't matter if I can reach any arbitrary peer, right? But for a video chat application, if I want to talk to you and I only want to talk to you, like I have to be able to connect no matter what. But if I'm in a torrent storm with 50 people, if I can't connect to 5 of them, I don't care, right? It's fine. But for Instant IO, I actually do hard coding a turn server. Twilio has a service where you can just pay them like 10 cents a month or something for a turn server. So that's just what I'm using right now.
You can reverse engineer the hello turn server from Tokbox for free in Firefox.
Isn't there? There's also an open source turn server you can just run too, right?
Yes, but then you pay the hosting.
Oh, okay. Oh, so you're saying use
in
Firefox?
Firefox there is hello, right? And Tokbox is providing the infrastructure. There is a turn server there that nobody pays for. So I'm saying that, I'm saying nothing.
So now we know we got that.
No problem.
It's no different than just using Google, which is publicly available. I mean, I'm not saying you should do that either.
No, I prefer to use yours. Because Google has no service level agreement to maintain a server, and they brought it down in the mailing list when people asked them, but Tokbox has. Again, you know.
Thanks, guys.
All right, so I have the big challenge to come at the end where I'm really starting after so many wonderful presentations. And my second challenge is I was too lazy to translate my slides, so I will use some slides I'm using in Tokyo, but I'll do the presentation in English. So I'm Alex, I'm the CTO of Temasys, a company that does a plugin, also propose the platform as a service and other things. And I'm not going to speak about my company at all during my slides. I'm also a standard committee member for all the working group there is around WebRTC, W3C, IETF, and so on and so forth. And that's a little more what I'm going to speak about right now, which is the status of WebRTC and what to expect this year. So I will go through the basic again. You saw all the extreme stuff, but this one is interesting. If you want Alice and Bob to speak to each other, and let's assume Alice is in a browser and Bob is using a device, right? You're going to need a web server and you're going to need a signaling server, right? So that part is going to be the backend, the infrastructure, and this part is going to be the client side of the thing. Yeah. But there are a lot of things. I'm sorry about that, but so there are a lot of things that are already defined by the different working groups, right? Whether it's the W3C for everything that happened in the browser, or the IETF with respect to the media path, or the signaling part, right? Including the SDP and the offer answer we already spoke about. And that,
direct translation.
if you really want, I can translate that in French and send it to you, but that was a little bit late notice. No, there are a lot of things that are actually not defined and that you need to come up if you want to have an entire solution. And that's where a lot of people come up with either commercial solution or actually very innovative things, because that's where you have the flexibility. Nothing is defined, nothing is forced on you. So the signaling protocol and the corresponding transport is actually open. Some people use JSON over WebSocket. Some people use zip over WebSocket. Some people use XMPP. There is a lot of variation of that thing here. The signaling server itself is not defined, so you can do a lot of things, and people put hybrid application here to bootstrap with other realm like BitTorrent and things like that. It's also open, and there is a lot of creativity that can happen there. One last thing, the WebRTC stack for the device when you're not on the browser is not defined, so you will need to find a solution to implement that. And some people will come in and say, oh, I want WebRTC to work in browser worker, for example, and send an email to the mailing list, and then we will have to step in and say, Feross, okay, we got it. That's a cool case. It's like WebSocket, and we're going to think about it. I want you to think about it now. Yeah, okay, we read it. Don't worry, it's coming. And that's cool. There's a lot of web people that are very passionate about that and propose cool things. But when it comes to devices, whether it's Internet of Things or it's a mobile or it's a gateway, actually, you're going to need to have an implementation of all those $192 million worth of technology that Google put in Chrome so far, and that so before. So global picture, you have good, but there's still a lot of things that you can have fun with. So where is it important exactly? There is the problem of the support of the browser, right? So if you look at the global browser support, or specifically in the enterprise market, you're going to see that the distribution of usage of different browsers is very different. So the web people will actually focus on that and say, well, you know what, I'm happy with Chrome, it doesn't work. It's been like that for 10 years anyway, so I don't have a problem for that. But people that want to do B2C or have a commercial offering for big enterprise, they're going to say, dude, I really need support for AI. And I don't have it today for WebRTC. So this is how important this is for me in the enterprise global market context. So what you can do, so this is what you have usually. This is the browser side. This is the backend side with the internet in the middle. Everything that crosses this line is defined on the W3C JavaScript API. Everything that crosses this line is defined on the IETF specification. You have your application that's going to speak to a client-side JavaScript API and a backend, API to speak with your single-link server here. And then you either have a WebRTC capable browser or ORTC capable browser, hopefully the next version of IE with a WebRTC shim on top, or, for example, the Temasys plugin for the time being. We provide a plugin that is free for the simple cases. We hate plugins. We're also trying to work with Microsoft and Apple to actually put the technology directly in the browser so we don't need to have that around anymore. I think we all agree that the WebRTC pledge is to have something that works natively in all the browser. And until that happens, a plugin will be, at best, an interim solution. So now, what is interesting is to see, okay, but Internet Explorer, I understand. What about Safari? What about mobile? What about things like that? Well, first, it's interesting to see the distribution between desktop and mobile is almost 50-50. But the rate at which the mobile is taking over is really, really high. So if I had to update that in 6 months, that will be much bigger. So a lot of people are then focusing on mobile first. Then if you're on mobile, are you using native or web application? Well, the numbers we got at the W3C show us that most people use native. Right? So today you have a solution for WebRTC native app, you have a solution for Apache for the hybrid and things like that. So the fact that Safari or WebView on iOS doesn't support WebRTC doesn't touch a big part of the market. Unfortunately, that's a part of the market that has a lot of money. So for people that want to do a business out of it, that's a little bit important. But in volume, no, not so much. If you're on mobile, it's a little bit different. So you have your application, whether it's Android or API, you still have the client-side API and the backend-side API. But now you have to replace everything that was provided by the browser, all that video, audio, data channel engine, all the protocols and everything. So today you really have only two alternatives, WebRTC, the library that is provided by Google and Mozilla, and OpenWebRTC that is mainly sponsored by Ericsson. Today, OpenWebRTC works better on mobile because they have support for hardware acceleration, which WebRTC.org doesn't have yet, even though they're working on it. But it's less mature. It also works better because it's based on a library called GStreamer for embedded in the Internet of Things. So you can have OpenWebRTC run a 180p 60 FPS stream on a Raspberry 2. The new one with augmented memory. So that's pretty awesome for a small thing like that. So we made a project, we teamed up with Ericsson to bring together our expertise to try to provide the technology faster to Apple in a way to maybe convince them to put it in Safari faster. So it's called WebRTC in WebKit, and it has its own website if you want to check the progress and the code and the discussion. And what we're doing is we're taking the WebRTC stack, both of them, the WebRTC and OpenWebRTC, and we're going to put it in WebKit, which is just a widget, the thing that corresponds to one tab, if you want, in a modern browser. And then we take one browser, this is the Linux browser, that uses WebKit as an example for a full browser, right? When this is done, what is interesting in all the other WebKit ports, including Safari, for example, would have access to that technology by a flip of a compilation flag. They still need to decide to do it, but at least the technology will be there and will be implemented. Also, in iOS, all the other browsers and all the other applications are prevented from using WebRTC because the Apple-provided WebView, which is mandatory to use by Apple Store rule, does not include WebRTC support. So that WebView being based on WebKit, this is the same source code. Apple could decide to provide WebRTC-capable WebView, enabling any iOS native app to use that directly without having to recompile that WebRTC library, which is really a value. Stun and turn, I put a few numbers about the capacity to go through the map traversal. If you don't use anything, basically it's going to work only if you're on the same map or on the same network. If you use stun, you're going to pass in 85% of the cases, globally speaking, on the global internet. For enterprise, it's actually less than that. And then you start getting into the turn and HTTP proxy that are mainly things that are used HTTP tunneling in enterprise, from easy to more difficult. And especially in Australia, where we have quite a few clients, since we're based in Singapore, all the hospital, the military, and the government have an HTTP proxy and require you to support that. That's 40 to 50% of the case in such big corporate enterprise. This is very often something that is overlooked. It's not by default in LibWebRTC. So if you compile LibWebRTC, you do not have support for HTTP proxy, even though Chrome has support for that. Right? So if you want to put that support into your mobile application or things like that, you will have to do that on the client side as well. And on the backend side, there are quite a few vendors today that provide separate Stern ICE API. But this one, you can cross out this one now. Then, like CRC and Twilio. So if you don't want to maintain it yourself, even though there is a very, very good open source server that all those guys use anyway, right? You can actually go there and buy an API key and access to it separately. So if you look at the big picture, where you're going to have the internet in the middle, then on the client side, you're going to have web, mobile, and native, like desktop or IoT, and here the infrastructure. You can look at a few people, look at everything I put before, right? So again, the application, front-end API, back-end API, the WebRTC capable browser, Chrome, Firefox, and Opera, and then plug-in for the rest. Android, iOS, native, and here all the kind of servers, signaling server, API server, billing server, media server, storage server, interoperability server for SIP and PSTN termination. I don't know what that is.
Bidding?
And load testing.
Bidding server?
No, the billing server is here. So if you look at AppRTC, which is the open source code that is provided for everybody, I mean, where you should start if you have nothing else, it's actually not bad. You have an entire web application, AppRTC. You have an Android version. You have an iOS version with the API and everything. You have the load balancing on top of Google App Engine. You can have the turn on top of Google Compute Engine. The code is also provided. But in terms of capacity of the backend, they're limited to the signaling and the API. So you would have to have a little bit more if you want to complete there. They also don't support Internet Explorer and Safari. Another example, an Entity Skyway. What people don't know is the offer from Entity Skyway is based on PeerCDN, which is an open source server that has both hosted part and an open source corresponding code. So they took the code and they modified it to have a few of the APIs. And I think less than 1 month ago, they announced the Android and iOS. And they have a turn server as well, which is entity technology here. And this is done by the research side. The Korean operator has the same thing. AT&T has something very approaching, but they not include video. You take a peer.in, that's originally focused more on the application. Now they're trying to open an SDK and they're trying to open a platform as a service. Everybody's trying to look, where they can make money here and there. They're still going very, very slowly, and so on and so forth. Tokbox, pretty complete. I'm sure they have some white label application, but they're a platform as a service provider, so their job is not to sell you an application. Their job is to help you actually build your application. And they have almost everything there, except interoperability with SIP, voice over IP, and PSTN termination. And load testing available from the client side of it. So they have a good dashboard, diagnosis, and everything. You cannot test with 2 million users. Go on my website and try to crash it. So what can we expect for 2015 in terms of API first, then in terms of non-API from the standard committee? You're going to have the recording on the client side, right? So the capacity to put on the file any stream that you acquire from your camera or from your hardware. And I will explain on the next slide why I'm making that difference. You will also have the capacity to relay anything you play in the video or audio tag. So let's say you're downloading or playing something from YouTube, or you're playing something. Now you're going to have the capacity to use that video tag and that audio tag as a source to make that streaming WebRTC. That opens, I see, that opens a lot of crazy use case. Where you're watching a movie, then you call you do that. What are you doing? Nothing, having a bed, watching a game, and then suddenly you can relay your movie, and everybody's looking at the same movie at the same time. You stay on and you can chat and something like that. The capacity to select the output device, which was not possible before, that's a nightmare. Most of the application that do not use a browser give you that capacity 10 years ago. And now you go into the browser, you use that. So people have expectation. That should be out this year as well. Statistic API. So the only way to actually know a little bit about bandwidth, to know about what's going on, which codec did you choose for me, by the way? Because pure connection is a big black box. You're supposed to get it through the GetStats API, which has never been fully specified or implemented. So everybody is implementing his own way. You have a lot of Google prefixed or Mozilla prefixed identifier there. Now that should be sorted out this year and go out. So people can actually make application that react dynamically to the bandwidth condition, to the network condition, to the bandwidth, to the type of codec, to the parameter, to absolutely everything, which you cannot do today. They should get their act together on a screen capture as well. It's been implemented in both Firefox and Chrome for almost a year now. They still couldn't get their act together on the specification side of things. That's really sad. The get user media part, which is the capture of the screen, they agree on. What they don't agree on is the security model for the browser, right? And that's the prerogative of each browser vendor to decide what they want to do. So of course, they decided not to do it the same way. So Firefox did a whitelisting. Chrome decided to push the extension model through that salt and pepper technology. And it would be very difficult for them to actually, at least for Chrome, to encode without that, because they don't have another way to have a difference in terms of security in the API call. The screen sharing is more dangerous than getting your camera. People get access to your camera, they can see you naked. Okay, not everybody like that, I'm fine. If you have a screen sharing and you do banking online or things like that, and you pair that with the camera, who is going to check if your eyes are looking at the screen or not, the moment you do that, boom, they take a screenshot, they everything done, and you don't have any money anymore. That's a bigger problem than being seen naked for most of the people. So we tend to apply different security rule there.
I don't get why the prompts won't work, but they should just ask, can I use your screen? And then if they say yes, they deal with it.
But that's exactly what I'm speaking about. That's the prompt.
How do they, if you look away,
yeah.
How do they click yes on the prompt when you're?
No, the prompt you do it at the origin, but after a while it's on. That's on.
You forget it.
Oh, you mean you leave it?
You load it, then you forgot it.
Yes. Plus, sometimes if you do it over HTTPS or one way or another, your authorization is persistent for 30 days. It doesn't ask again. And that was at the beginning of the plugin 1 year ago. Some people were coming up with plugins that didn't have the prompt. They said, because the prompt is, people don't like it. Yeah, people don't like it. So what we did in our plugin, for example, we implemented a whitelisting, right, for the security instead of the prompt, right? So at least I know you're on the right side, and it's hard-coded at compilation of the plugin. And then I don't bother you with the prompt if you don't want to. But that's because I have another way to actually check if you're accessing from the right place and if you're authorized. Yes?
I was just going to say the security risk there is what it boils down to is a violation of the same origin policy. And it's really roundabout how that actually works out. There's a really good post from Elise Ecker at Mozilla that describes it in a Mozilla report better than I could. It's quite people trying to realize how it actually violates.
So we worked a lot on possible use case because everybody was like, first, what can happen? Two, what's the frequency of that happening under which conditions? So you have a document within the IETF working group, which is security, and you have 3 use cases that describe exactly what can happen and what we want to avoid. So for all the WebRTC implementation, there is a use case and expectation document first before we write the specs, or we try to avoid the scenario where an asteroid will hit the word, that will never happen, or doesn't matter so much. So you can refer to that document.
I don't want to dwell on this too much, but couldn't you just say, okay, don't persist this permission? You allow it, and then the minute you can leave the site, it loses the permission.
If you do it over HTTP, that's what happens anyway. You're going to get prompts all the time.
Just do that for HTTPS too.
For screen sharing and for
screen sharing, it's higher level, so you have to be on HTTPS. That's it.
Sure. But I mean,
you would be surprised how many people are reaching one way or another, depending where you put the cursor. So we know we did the right thing when we have as much reaching from one side and then from the other, right? Find the balance. So if we do what you said, we're going to have a lot of people say, that thing's annoying, I keep clicking, I told him, okay, why do you keep asking me, right? And that's the vast majority of
it. At least it's possible, right now, if you need an extension or you need a hard code list and compile things, it's not easy at all. It's impossible.
In Firefox, it's easier, because if you accept and you say put it in a whitelist, you don't.
Oh, it's not, I think you said it was a compilation whitelist.
No, in our plugin.
You still get a prompt on browsers with screen sharing.
You still get the prompt, even if it's whitelisted? Okay.
Because the selection UI is actually provided by the browser, so it needs like the source as a user, and the dialogue there is provided by the browser.
Fair enough. It's still in flux anyway. There's a lot of those things that are going to change at the end of the year, and I'm touching that on exactly the next slide, the 2 next slides. Those are non-API improvements. There's a lot of work on hardware acceleration. There's a lot of work on additional things that are not visible will improve the quality of the audio, the echo canceling, and things like that. And finally, there will be new codecs and new media style coming in that will help keeping the same quality but using less bandwidth or bring in some other things. This is quite technical though, and that plus the new design for WebRTC that is going to be right now. You have a black box here that is called peer connection, right? And there is a lot of things you cannot decide. You cannot touch on bandwidth. You cannot touch on codec directly, really. You cannot touch on a few other things where people's the fingerprint certificate for the encryption, things like that. So people say this is too high level. People are starting to manipulate the SDP to be able to do what they want to do because they don't have the corresponding JavaScript API. Right? Problem number 1. Problem number 2, we hate SDP and we hate offer answer. We want a way for people to send directly information, even without doing an offer answer, and I can actually decide to take it if I want. Maybe something you might be interested in. To be able to do that, plus 2 other use cases that WebRTC cannot do today, which is simulcast and SVC codec, where you actually have different media stream, video stream that depend on each other, right? That you cannot do today with WebRTC. They took that. They said, okay, we're going to break peer connection and expose a little bit more. There's going to be the pure encryption, which is corresponding parameters. The fingerprint, the certificate, and things like that. The ICE part, hey, don't show my public IP, only use turn, do this, do that, you know. The capacity, well, it's a bit more complicated for ICE. In the case of data channel, you have that layer on top that is not only have an extra security, but gives you the capacity to handle order versus unordered, or binary versus ASCII, and all the option you have right now that are complicated because you give them at a place in the code where you're not expecting to give it. Same thing. You can ask for the capacity, and you can get or set parameters. And you build your pipeline yourself. Because this is exactly a lower level of WebRTC, people will be able to make a JavaScript shim on top of it and do everything that WebRTC was able to do. So that's why Microsoft say, I'm going to implement that, and people do the shim, and you're going to be good. No, there are those 2 cases that you can do with this that you couldn't do before, right? So
I think there are 2 things here. Get rid of SDP,
yes,
which is the major win here.
And everybody is so happy about that. And that's really great. And because you don't need to manipulate and do all these hacks, and it's much easier to actually build something. And then there's other things to expose and to expose the metrics, and then specifically on the reliable and standard level, it was for a few years it's already okay.
It's okay, but
and also the get stats, it's partial, like was exposed partially, but
it's okay. But if you take the example of data channel, which is the one that touched you two most, right? Firefox or Chrome have a different approach. That if I set the data channel here, does it automatically set the data channel on the other side, or do I get the event and set it? It's not symmetric, you know, and things like that. So there's a lot of things that were cumbersome that you don't think about it anymore because you solved that problem, but the problem exists for every people that is going to comment. Yes?
I'm a little bit confused here. WebRTC is Microsoft implementation, or is it now a joint Microsoft and Google? At Cranky show last year, when you presented, I thought they announced that they had an agreement with Microsoft.
So here's the status. WebRTC is a community group of W3C. So it doesn't have anything to do with standards. Anybody, and them all, like the bro, can start a community group and speak about things and write documents. So people that were not happy with SDP and the level of granularity in the pipe said, we don't want to wait for the other people to realize and then start the work. We're going to start the work ahead. So when the people realize that it's not a good level of API, we have something ready. But they cannot decide to put it into the standard. So originally, Hook Flash, so Lagaway and I never remember the name of the second guy, started that group with Inaki Ibanez and a few others, and Ericsson. Then eventually toward the end, when the group started to get closer to each other and wanted to go in a convergence path instead of a divergence path, they remove all the original author of the WebRTC draft. They only kept Hook Flash, and they had Justin Uberti from Google and Bernard Aboukhadijeh from Microsoft. And then Microsoft made them their new things, but they didn't initiate the work. No, it doesn't change the fact that this is a good design, and the people that were in the WebRTC standard working group realized that that was answering a lot of the problems that were on the table. So we decided to take that in a little bit earlier. And so we used the work that was done very well in the WebRTC group to bring it in. 1 month ago, the WebRTC working group at W3C had to ask for renewal because he came to the end of his mission. They took the opportunity to change the charter a little bit to include the scope of the WebRTC working group in the scope to add that. And so they brought in some people from outside. They brought the ex-NET CEO, Peter Santandre, as an editor. They brought Eric Lagaway from Hook Flash also as a member in here. And they finished the convergence of the thing. So the new charter that is in place right now actually includes people for both groups, and it's likely that there will not be any difference in the future. So that's the total answer. There is a face-to-face meeting of just that group in September in the US, where we're going to validate all that. Google has an implementation already, but they didn't put it in Chrome. Microsoft and Hook Flash has a different implementation that is a standalone C++ library just for WebRTC, which is not the same stack, right? And that for W3C to accept an implementation, you need to have at least 2 different stacks in 2 or 3 browsers to have enough difference to make sure that the spec is good and it's not a specific case. We have the technical plenary in October in Japan, where that should definitely be in the browser right now. So that's the calendar for the rest of the year.
So is there something called WebRTC 2.0?
So one of the reasons why we're writing the chapter to 2 months is because people disagree about the naming of the new WebRTC. Some people wanted to call it WebRTC 1.0, 1.1, 2.0, next generation, and so on. And it's actually, last 1 month to decide which name was new. So I think they finally end up with next generation or something like that. At the end of the day, it doesn't matter. That's the design.
So why the title?
There is no date on it. There is no date. right? And every people have different priority. So Microsoft has get user media in the next IE, but they had get user media in IE since IE 10, right? It's been a year already that HTML labs had that as a plugin, ironically enough, but they had it. I know for a fact that the peer connection side of things is not get user media is local. Peer connection is more complicated because there is a network part component of it, right? It's not ready. And it might not be ready for 2015. So that's why it's called a long shot, since this is about what you should expect for 2015. So because of the calendar and because of the maturity of the code, I don't think you're going to have that in the browser before next year. All right, so sorry for the Japanese again, but that's why it's cool. That's about it. Cool.
What kind of discussions have there been about enabling WebRTC
In the back end?
in the background?
Can you repeat the question?
What kind of discussion, if any, has there been about enabling WebRTC in the background? I think a lot of people have requested the capacity to put WebRTC process in a worker, whether it's a shared worker or a different kind of worker, whatever. The discussion is still ongoing. But the basic idea was, it looks like WebSocket. It tastes like WebSocket. WebSocket can do that. I want to be able to do that with WebRTC as well. So Feross asked officially the question on the mailing list a few days ago. And member of the working group have said, why not? There are some security considerations that the browser vendor have raised so far, but it doesn't look too big that we're not going to speak about it. So Sylvia from Australia, with the HTML5 video expert, actually support. So it's very likely that it's going to be at the agenda of the next meeting in September.
Awesome.
And I personally don't see any reason why not, but there is really two WebRTC security experts. One is Eric Rescola from Mozilla, he's really the #1. And the other one is Justin Oberti from Google. So those two will need to give the green light before it really actually happens in the browser. All right, thank you guys.
It was really informative. Thanks.
Hey, no problem. Good. People tell me they usually don't get to see what's happening behind the curtain.
Yeah, that was the most interesting part.
Sometimes you wonder, but what are they doing exactly? Why are they doing this?
Yeah. I still think that the screen sharing thing is silly. I think just every time you want to screen share, you ask for permission.
Yeah.
And then
it's really an